Bismillahirrahmanirrahim. This is Tahir Samoo, lecturer of chemistry from Nabi Bagh ZM Government Science College, Sadar, Karachi. Today I am going to discuss first year chemistry topic, that is hybridization and its types. What is hybridization? Hybridization is a chemical process in which orbitals of different shape and different energies combine to each other in such a way that these produce new hybridized orbitals of same shape and same energies in equal numbers. There are three types of hybridizations that are included in intermediate course: sp3 hybridization, sp2 hybridization, and sp hybridization. We will discuss one by one. sp3 hybridization is a type of hybridization in which one s orbital and 3 p orbitals mix to each other and they form four new sp3 hybridized orbitals of same shape and same energy. As we know that carbon have 6 electrons and its electronic configuration is 1s2, 2s2 and 2p2. And we also know that in chemical bonding process always last shell electron participate. So 2 shell is the last shell of carbon. We will consider this last shell. In the last shell, carbon has 2 electrons in 2s and 2 electrons in 2p, and this is the ground state of carbon. We know well that during the process of bond formation, when electrons have vacant orbitals, they get shifted themselves in those vacant orbitals. This is basically Hund's rule. According to the Hund's rules, electron will always jump to the vacant orbitals whenever they will find a vacant orbital. So in the last stage, the process of hybridization takes place in which one s orbital and 3p orbital, one s orbital and 3p orbitals of carbon atom will mix to each other and they will form four new sp3 hybridized orbitals of same shape and same energy. For sp3 hybridization, we always discuss methane molecule in which carbon have 4 sp3 hybridized orbitals. This is 1, this is sp3 hybridized orbital 2, this is sp3 hybridized orbital 3, and this is sp3 hybridized orbital 4. These 4 sp3 hybridized orbitals will make bond, 4 sigma bond of s orbitals of hydrogen atoms. 4 hydrogen atoms will make bond, sigma bond, with these 4 sp3 hybridized orbitals, forming a tetrahedral geometry and bond angle of 109 point something. The summary of sp3 hybridizing orbital is sp3 hybridized orbitals occurs when a carbon has 4 attached groups. sp3 hybridized orbitals has 20% s and 75% p character. 4 sp3 hybridized point toward the corners of the tetrahedron at 109.28 to each other. Each sp3 hybridized orbital is involved in sigma bonding. So before we proceed for sp2 hybridized orbital or sp2 hybridization, let's understand what is sigma bonding and what is pi bonding. Sigma bond basically is head-to-head overlap of orbitals, atomic orbitals, and this can occur when s and s meet head-to-head. They form ss overlap orbital, and sigma bond can also be formed when two p orbitals meet head-to-head, and the third possibility is when s and p orbitals meet head-to-head. So whenever there is head-to-head overlap, we will have a sigma bond, while pi bonds are formed when two p orbitals overlap parallelly, side by side bonding. This is basically side by side bonding. When two p orbitals mixed each other side by side or parallel, it is known as pi bonding. When pi bond is formed, they form a cloud over the molecule. This is electronic cloud that is formed after the pi bond formation. Now sp2 hybridization. sp2 hybridization is a type of hybridization in which one s orbital and two p orbitals combine and they form three sp2 hybridized orbitals. As we know that in the previous example, carbon has 4 electrons in the valence shell, and as there is one vacant orbital, that is 2pz. So according to the Hund's rule, the electron from 2s will jump into 2p or vacant orbital as excited state, and in the last, when the process of hybridization takes place, here one s orbital and two p orbital will mix to form three sp2 hybridized orbitals. They will form three sp2 hybridized orbitals, while the 2pz orbital will not participate in the bonding and will make a pi bond. Here we can see the example of ethene, in which each carbon have 3 sigma bonds because of 3 sp2 hybridized orbitals. This is one sp2 hybridized orbital, this is second sp2 hybridized orbital, and this is third sp2 hybridized orbital, while the fourth electron in 2pz orbital will make pi bond. So in ethene molecule, basically there are 1, 2, 3, 4 and 5 sigma bonds and 1 pi bond. So pi bond is parallel overlap, and this is a weak bond as compared to the sigma bond. Sigma bond are very stronger as they or form head-to-head overlap. Here is the summary. In sp2 hybridization, there is 33% S character while 67% P character. The molecules are planar when there is sp2 hybridization, while the bond angle is 120 degree, and we can also find a double bond when there is sp2 hybridization. Now sp hybridization. sp hybridization is a type of hybridization in which one s orbital and one p orbital mix to each other. They form two sp hybridized orbitals. So here we can see electron from 2s jumps to 2p z according to the rule of the Hund's rule, and in the last stage electron in 1s and electrons in 2p are involved in the bonding, and as we can see that as a result we will find two sp orbitals, while 2py and 2pz orbitals will make pi bond. They are not taking part in the hybridization. So ethine is example of sp hybridization where each carbon have two sp hybridized orbital. This is one sp hybridized orbital, this is second sp hybridized orbital, while py and pz orbital form a pi bond over the molecule. So the geometry we can see here is linear, and the bond angle will be 180 degree. Here is the molecule of ethine, also known as acetylene. In ethine, each carbon makes two sigma bond, and py and pz orbitals form pi bonds. So in ethine molecule there are 1, 2, 3. There are 3 sigma bonds while 2 pi bonds as a result of overlapping of py orbitals of 2 carbon and pz orbitals of 2 carbon. So here is the summary. In sp hybridization there is 50% S and 50% P character. Bond angle is 180 degree, and we see one single we can see 3 sigma bond and 2 pi bond. A triple bond means 1 sigma and 2 pi. At the end we have a summary. Single bond means end-to-end bond, head-to-head bond. Double bond means 1 sigma bond and 1 pi bond. Triple bond means 1 sigma bond and 2 pi bond. Thank you.